Alright, time for another DraftPhysics.com video presentation. Debate physics also, and we have a little bit of a debate. I mean, there is at least some sort of attempt at a counter argument, but it's really not on the subject, frankly, and so, not very useful. So the Ian Gostlings has made another video, and I'll play it, but, there's bits of it that really aren't very useful. So I'll play it faster, maybe.
Now then, this is the second time I'm recording this, Gary. The first time I didn't consider I was condescending or arrogant enough. This seems to be quite necessary, really, because in discussing things with you, you're quite obstinate in your lack of ability to agree on like basic things in reality.
Yeah. Well, again, you can't even follow along with a simple rain analogy, and recognizing that it's about a distance, a specific distance, not an infinite distance, but a specific distance. And you can't even obey those simple rules, A to B, and instead you do A to infinity. So, fuck you.
I do wonder whether it's something to do with your... I'm not casting aspersions, but you...
Oh, yeah, fuck you. Okay, maybe it has something to do with, whatever. Your mother shoved St. Christopher medals up your butt when you were a little kid or something. Who knows what your perversions are, fuckhead.
I've talked about your smoking as a teenager, and it's well known that the brain develops up until about 25, and an excess of that can affect...
An excess of what? Well, where did I say I smoked an excessive amount of anything? Who knows? And what are you talking about? Smoking pot or smoking what? Smoking cigarettes? There's no direct correlation between cigarettes and any form of brain damage. So again, you're just making crap up now.
Way that the brain would work in dealing with reality. But anyway, this is not about...
I mean, you could make the argument that statistically most of the greatest scientists smoked cigars or cigarettes. Most of them did.
Throwing insults as such. This is about the force. This is a lever system.
Yeah, it's just drawn in totally useless form. Okay, it doesn't have anything to do with the real lever. So I've already explained this, so I'll go through it again. He's missed the entire point. He thinks that being higher in gravity means something. It doesn't mean anything. Something isn't way more because it's higher in gravity or lower. Being here or being here doesn't make any difference. It's the same exact gravity. I mean, to all rational perspective it is. I mean, technically this is a billionth time, a billion times. This one's a little heavier, the lower one, not the higher one. So there's no reason for the higher one to fall. So it won't, as a fact, if you have an ideal lever, that is a invisible one that doesn't weigh anything. This can't oscillate, it can't do anything. It's completely not going to work. The only thing that makes it happen is it's actually the lever. So the less lever you have, the less capacity you have to create any kind of substantial energy in the oscillation. Those are the facts. I'll be back. Alright, so he's going to argue that this balancing a lever thing and the movement of the objects is something to do with some distances and heights, and no, it has nothing to do with any of that. So as I tried to explain, you just have to understand that the lever is a physical object, the balance. And critical to any conversation is recognizing that at any point, if there's more mass above the fulcrum, the center, the lever will not balance. The balance won't work. This can't be a balance. Okay? Balancing the lever this way won't work, because when it tips this way, it puts more mass on this side of the lever. You can understand that this mass over here, when this tips down, this mass becomes part of this side. And so now it's just getting heavier and heavier. So as it swings down, it's getting mass plus. It's getting heavier. There's more mass on this side. So it just keeps going because there's nothing to counterbalance it. Now, if I put the fulcrum up here, all right, so most of the mass of the lever's below the fulcrum, the exact opposite happens. So now, when this goes down, okay, more mass goes on this side. This whole section here becomes part of this section. This hunk of mass moves to this side. So now this side becomes mass plus, and this side becomes mass minus. So this side's getting lighter as this side's getting heavier. That's what makes this stop and then go back down. It's because it got heavier, this side got lighter. Now this side's heavier, it's going to want to push, it gets pushed harder by the gravity down. And exactly the opposite thing's going to happen again. So it'll go through the neutral point and then it'll start going down. The other side will go up. This side will get lighter. This side will get lighter. This side will get heavier. And it'll just keep oscillating. So what you're really doing is oscillating this. You're moving this hunk of mass from this side to that side, to this side to that side. That's what's oscillating. So this is the energy that's oscillating, the source of the energy. The equal, say you had a 5 mass here and you had a 10 mass here, okay, they're equal. They're not doing anything. It doesn't matter where in space they are. That's not going to make any difference because of this distance. It's still twice the distance. So the 5 at twice the distance is the same as a 10, so that balances. And that continues to balance no matter what position it's in. And the only part that's unbalanced is this. Now I observe this because I put a 2x4 on a fulcrum, okay, and I noticed that the damn thing doesn't work at all as a balance. It completely fails. And it's because you really do have to hang it up here, or you have to put some structure to hang it. Then it'll work as a balance. But it can't do it from down here because the side moving down gets heavier instead of the side moving down getting lighter. And so it won't oscillate. So for it to oscillate, the center of mass of the fulcrum has to be above the center of mass of the lever, so that way more mass can switch sides depending on what side is moving in what direction. The one going up gets heavier, the one going down gets lighter. That's why it oscillates. And this is the energy. The energy doesn't really have anything to do with the 5 mass and the 10 because they're equal. The energy is just about this mass switching sides. Alright, so that's the first part of his argument. Now the second part is the much more important part when it comes to the kinetic energy argument. So in this case, we'll just argue that you have a light lever. It doesn't really matter, but yes, let's just say, and we're just going to do the typical 10 and 5 thing. So we have a 10 here, we have a 5 out here, and the argument is we put it into oscillation. So we have a fulcrum above the center of mass of the lever, okay, so it will oscillate. So we have it in a mode that's oscillation. It creates oscillation. And the energy of the oscillation is really just that mass switching sides. Now the point is that as this swings with twice the velocity, so it goes twice the distance in the same time this goes this distance. So we have a guarantee of twice the velocity, half the mass. Now the thing you have to explain, jackass, okay, is that nothing changes for the lever. Nothing substantial. There's no substantial. We've made this lever not a big thick piece of 2x4. We made it as small and light as possible, so it's the amount of its mass switching sides is as minimal as possible. And so all you have is the 10 and the 5, and you have it oscillating. Okay. The simple point is I could stop it by putting a stop in. So it's oscillating, and then I put a nail in. Now it can't oscillate anymore. And you could understand that when it can't oscillate anymore, I stop it at the maximum velocity, that if this object were free to fall off, okay, that it would leave with twice the velocity. So you'd have a half mass, a 5 mass, with 2 velocity. And here, because of this stop, this mass is going to be going this way, okay, and it's going to have the 5 velocity, well, the 1 velocity, and the 10 mass. All right. So this has more kinetic energy, twice the kinetic energy. So the point is whether I stop it here and I let the lever impact, it would be identical as if I put the stop here and had it stop because it hit this nail here. So whether this is going down or whether this is going up, the nail, or whatever I have as a stop, is going to feel the same exact force, because it really is both objects moving as the total force. And whether I stop it with the nail here or I stop it with the nail here, the nail is going to get hit with exactly the same force. So you can't use that as a place where you lost the energy. So you still have to explain, okay, how can I get twice the kinetic energy out of the system, okay, over here that I have over here? How is that possible? That in the two scenarios, the total energy that I'm going to get is not equal, when the system had to have equal energy. The system had to, because it was moving this mass, this mass was shifting sides. It's the same amount of mass moving from one side to the other. So you can't say it's a different amount of energy, because it's the same mass falling the same distance. The mass that's shifting from this side to this side is always the same mass. So the can't create a different amount of momentum or energy, because it's always moving the same velocity. So you have to explain how you get these differentials. And that's what you're not explaining, is how can it have an unequal amount of energy on one side as it has on the other side. If I need to say more, I will. I'll leave it at that, yeah. But the rest I should be able to illustrate with words and such. Alright, hit the button.
An oscillator. These are weights hanging down from this bar, shall we say. It could be of infinitely small mass. Because we're going to talk about I suppose it's a bit of...
Okay, so I'm just saying, right there you're wrong. If I make the bar an infinitely small mass, that is, if I make it as light as nothing, it won't oscillate. So whatever energy put in, it'll just go around in that direction. It will never oscillate, because it needs the weight of the lever to throw the mass on the other side to force the reversal. There's no reversal in direction without the lever having a real mass. Lever has to have a real mass, because it's the mass of the lever that's moving from one side to the other.
The mathematics of it, although I'm not a mathematician, but...
Yeah, you're just reciting gobbledygook that you've heard somewhere, and that's it. These angles don't make any difference. None of it makes sense. We're talking about causes again. You just don't get the difference between talking about an effect and talking about a cause. The cause of velocity and momentum and kinetic energy when you fall in gravity, the cause is the amount of time you're getting exposed to the gravity. The cause of sunburn is the amount of time you've been exposed to the photons. That's what decides. That's the cause. And in this case, the cause is the lever. Without the lever, there's no balance. The balance can't work. The balance can't oscillate, let me put it that way. You could make it balance, But as soon as you put energy in either direction, it will just keep spinning in that direction without the lever being heavy enough, having enough mass to throw more mass on one side than the other.
This would come under more of the study of what's called graphic statics, which is the ability to work things out in engineering by drawing lines.
Oh, look, force diagrams are, a standard part of physics. Nothing new.
Lines. So it's a bit of geometry, really. So these two masses are the same on either end. This dot represents the center of this mass. Same.
Doesn't matter where that center is. It just matters where the center of the fulcrum is. Whether the fulcrum is below the mass of the lever or above it. It has to be above the mass for you to have a oscillating balance.
On here, this is the fulcrum. This line is reproduced down here in the length of this line in the same masses, in the same center of mass. From here to here, we've got a 45-degree roughly displacement, and we'd want to know.
Irrelevant, but I'm just saying the displacement is really here at the lever. So when you cut this line, you can recognize that a piece of the lever that was on this side is now on this side. When you have this lever on top of the fulcrum. See, you drew it with the lever on top of the fulcrum, which again means it's going to keep spinning. The fulcrum has to be above the lever. So if the fulcrum's above the lever's suspended below the fulcrum, then it will oscillate.
What that would do if we...
Well, then it can oscillate. If you put enough energy into it, it'll go around and around until the energy dies down enough where the mass of the lever can switch from side to side and make the difference. But if you put enough energy in, it'll make 2 or 3 cycles before it starts to oscillate.
Froze time, if you like. We want to know what the force acting on this lever would be. It's quite simple. It's the product.
That's just nonsense, so it isn't. It's not the product of any of this crap.
And the product is a combination of two things multiplied together. The product of the mass of this weight and what's called the arm. And the arm is the distance between the center of mass to a line going through the...
So understand, he's just describing a symptom again. So this is as dumb as, again, saying, well, it's 4 times the distance in gravity, therefore it's 4 times the energy. No, it's only twice the time, only twice the velocity, only twice the weight. The 2's are the thing that are showing you the elemental cause of the energy, the time. And again, you're missing the point. Yes, of course, you can diagram the wrong thing because the right thing is going to do something very similar. It's a little triangle over here that's going to change which side of the lever it's on. And that little triangle will be representable by these distance lines, but the real cause is right here at the fulcrum. Right? The fulcrum is the cause. The pivot.
Fulcrum. And this is a perpendicular arm to the line going through the fulcrum. And that's called a moment.
Yeah, it's just more nonsense and more gibberish, more baby talk. A moment. There's no moments involved. There's just the simple fact that when the lever's below the fulcrum, every time it oscillates, every time it turns, it puts more weight on the side going up and less weight on the side going down. Every single time it turns, that's what's going to happen. When it's hanging from above, the line makes this heavier and makes this lighter. And that's why it tilts back the other way.
You used to have trouble with that word. It's not like
yeah, it's useless gibberish. Yes.
A moment you have in an emotional sense. I'm having a moment.
Look, if you want to defend their language, you can go ahead, okay? But I don't think there's anything about it's defendable. It's not a real good word in any respect. It doesn't really describe what's happening, so why call it a moment? Because it really doesn't have anything to do with it.
It's a turning force, if you like.
Yeah, so why don't you use the language that you think makes more sense? But there is no turning force. The turning is a consequence of the fact that you're using a rigid armed lever, and it has to turn. It doesn't have a choice. There's no turning force. There's just the momentum, the velocity given to the object. It turns because it's not given the option to not turn.
In this system. So we could measure the product of the weight and the centre of mass and the arm, and we could compare it to this side, and we see that this side is more. We've got 45 millimetres I've measured as compared to 35 millimetres.
Then you did something wrong, because guess what? Those angles have to be the same, which means the arcs have to be the same. So that's just not very good measuring, frankly. He's saying from the center. Where did you ever do this experiment with equally sized masses and all of this crap? It obviously doesn't have anything to do with it. This part has nothing to do with it. That change in the shape of the object, whether I turn this way, it doesn't matter which way I turn it, the same amount of gravity is going to hit it. It has absolutely nothing to do with it.
Which means there's a greater force acting on this side.
Really doesn't, but whatever. It's a mass in gravity. You can't have a greater force hitting it. It can only be one force. It doesn't matter which way I move it, how I move it. The real event is at the fulcrum.
And it will in fact start to return as a restorative force to horizontal. It now has momentum, so it will carry on. And as it carries on, this side, the product of the arm and the mass, starts to increase, slowing it down till it would reach somewhere like that, stop, and then it would descend. And it would oscillate backwards and forwards until it lost its energy.
Says you. I mean, realistically, this has nothing to do with most of the experiments done. So I'm just saying this obviously wouldn't, like even when I did the oscillating lever, they didn't stick out like this. They were free to stay in line with gravity. So their alignment was always in line with gravity. So none of those angles would change. And it oscillated just fine.
And also, as I've mentioned in other videos, we had this argument: if the centre of mass of the weight would be here in a line with the fulcrum, it would not oscillate. Whatever position we put the lever, it would.
No, that you have it the wrong way. Whatever you have it below. If you have the lever below the fulcrum, it oscillates just fine. If you have any portion more than half the mass above the lever, it won't oscillate. So if more than half the mass is above the lever, it's not going to oscillate. If more than half the mass is below the fulcrum, it will oscillate.
Stay there. And if anybody doubts that, go back and look at the videos I did where we...
Oh yeah, well fuck you, don't waste your time. He just keeps making the same arguments over and over again. Says, look how great my argument is. It's the same damn argument, and it's already been defeated.
Did a physical demonstration proving that the centre of mass has to be below the line going through the pivot.
Said it again, but yes, it's true. That what he just said is true. The center of mass of the lever has to be below the fulcrum, the pivot point. That's true, but how you're showing it isn't that. You keep showing it with your pencil in the wrong place.
Fulcrum. If it's above, it'll turn over completely.
Yes, exactly. The balance doesn't work if it's above. I mean, it doesn't work if you give it any motion. So you could perfectly balance with a fulcrum at the base, but if you give it any energy at all, it'll fail to recover. It will not oscillate.
It's unstable. If it's below, it'll oscillate. If it's in line, don't do nothing.
Of course it does something. So to say it doesn't do nothing would be idiotic. But the fact is it won't oscillate. There has to be more mass below the fulcrum, the point of the fulcrum. There has to be total more mass below it than above it, or it will not oscillate.
The meat and potatoes of this video is this system, which you are often asking about.
So this one, why would I even do this? I have one mass above the lever, one mass below the lever. It won't balance in that position. It'll balance crooked. So you didn't even get that part right.
Somebody to tell you how it works, or draw a picture, or explain it. Now the problem might be in, first of all, understanding exactly what it is you're saying, Gary.
I'm saying it can't be an oscillator if there's more energy on one side than the other. That oscillators can't work that way. They have to move. It's like a coupled oscillator. All the energy is essentially put on one side. So as the object lifts up, it comes to a complete halt. That means this side has zero energy to give. And so now this side is going to regain energy from the force of gravity, because this side now has more mass on it. The lever's heavier on this side of the fulcrum. So now that's a new set of energy. It's going to fall. And that constantly moves from one side to the other side to the one side to the other side. And it can't do so where it has twice the energy when it's on the right side and half the energy on the left side. That's irrational.
By no means intuitive, and it's been by no means quite rational or logical even. So I'm trying to read between the lines.
Yeah, whatever. Fuck you. You're not even coming close. I mean, frankly, I make a whole point about traveling a distance, okay, and then using speed to travel the distance, and then he basically says, well, let's just pretend there is no distance, and they're always in the force. Well, yeah, then they get hit by the same amount of force. If I can't change how much time they're in the sun, then they're going to get the same suntan. It doesn't matter whether one guy's walking around in circles or the other guy's just laying in a chaise lounge. If all I say is, well, they're both in the sun for the same exact amount of time, yeah, then it doesn't matter how fast they're walking. Idiot.
To see what it is you are saying, to be able to discuss it. So you have to cut me a little bit of slack, because I'm trying to understand. Now, in this lever, we've got the half mass, two distances, and the one mass, one distance. Classical balanced lever, if you like.
Yeah, well, no, it's not classical. So again, I don't. Why did you draw it this way? Why did you do this? It has to balance on the center of masses, so it won't balance that way.
Now, these masses in this first example are stuck to the lever. They're fixed, attached. Now, if we gave this a force, this lever, an impulse, and displace it, what I think it is you're saying.
So he didn't even describe this lever, so we don't know where this fulcrum is. So again, it has to be, for it to be a balance, it has to be above, or it's not going to work as a balance. It will fail as soon as you're putting energy in. The balance will be destroyed.
Is that because this half mass has twice the kinetic energy than this mass does?
Right. So I'm going to, in one case, create twice the energy that in the other case I'm going to create. I do the same experiment. I'm just saying, I put the stop here. I stop this from going up. All right. The fact is, this leaves with twice the energy that it will leave when I stop this one from going down, you could argue. So I could just put this horizontally, and you can understand. They have a motion. I'm going to stop their motion. The stopping of the motion is going to be exactly the same force to stop. And yet, one side I stop it, there's going to be twice as much energy produced. You have to explain where the extra energy came from, or you have to explain how the energy was destroyed. Because it has to be somewhere, as Feynman would say. You got to account for all the blocks you started with. You have a certain amount of energy, you have to account for it.
Due to the fact that it's going at twice the velocity, which would give it 4 times the kinetic energy, but it's half the mass, so it's half the kinetic energy. What it is I think you're saying is, why doesn't it keep going?
No, that's not what I say. So that's not my argument at all. I never made an argument anywhere like that. I said if I stop this lever from moving, and just these things fly off, they're going to fly off with uneven amounts of energy. That's the part that's paradoxical. Doesn't make any sense. Can't be possible.
Is that what you're saying, Gary? If this has got more energy than this one and they're attached to the rod, why doesn't it keep going?
No, I never said that. Never made that argument a single time in all these videos. I never said that.
Well, what's your...
So I don't even know where the guys that from. I was just kind of funny. I mean, I suppose it's a good question. I mean, if there is twice the kinetic energy and the item is stuck on this lever, then why the hell, why wouldn't it stop it from oscillating? How does this have the power to stop this from oscillating? And somehow it does. Now, as I just explained, what's really stopping it from continuing to go is that as far every inch it goes up, gravity is going to push it down because it's getting heavier. So if it was horizontal, then there's no effect because there's no gravity to recognize the increase in the mass.
Remember there is that this weight is acting in a direction in addition or in compliance or in congruity with this weight.
Yeah, but that's the part that doesn't stop it, right? That's the part that, obviously, if that was as simple as it was, and that's all there was to it, then it would just keep spinning. It would never oscillate. We're talking about an oscillating lever, not a rotating lever.
They're in opposite directions taken individually, but they're aiding the lever in the same direction. For instance, if we give this an anti-clockwise...
Look, if I let this side hit me with the half mass further out, or I let this side of the lever hit me at the same location, it's not going to make any difference. I'm going to get hit with the same force, because I'm going to get hit with the total force of all the mass moving. So the velocity of all of the mass, all the atoms moving, the total net momentum is what I'm going to get hit with. So the total momentum is this object plus this object is the total momentum plus the movement of the lever. And the simple argument is if I stop the lever from moving, what happens to the energy? Well, this isn't going to start going twice as fast. So it's going to end up with a lot less kinetic energy. Now, momentum says everything's just fine. This leaves with twice the velocity and has half the mass. That equals one velocity and one mass. No problem. A full mass, a two mass.
Impulse. The lever will turn in anti-clockwise. But this weight is now assisting the lever in anti-clockwise, and so is this one. This weight.
So again, in none of my videos did I ever talk about spinning the lever. Always talked about an oscillating lever. Always. Every single video. And the only point I made in the spinning lever is that if I did make this flywheel where I put a one mass and a half mass on the outside, that the flywheel will collect momentum, just as much momentum if I put two fives out here or I put two heavy masses on the inside, that it will collect the same momentum. That's the only argument I made.
Is assisting the lever in an anti-clockwise direction. They're both acting in unison. They're not fighting each other, Gary. It's not a case of seeing which way.
The very premise of the oscillator is that they're fighting each other. That the fact is that the lever has more velocity here at the balance at the midpoint, and it loses velocity the higher up it goes. It loses velocity the further down it goes because the circumstance is being changed because the lever is moving the mass from one side to the other. So it's making the side that was lighter heavier, and it's making the side that was heavier lighter. That's why it oscillates.
Would win. They can't win. They're both going in the same direction in respect to the lever.
So again, I haven't made a single video talking about rotating a lever. Not a single one.
Because they're both going in the same direction with respect to the lever, if we gave it enough energy, it would, in fact, revolve. And we would have something what would be...
And we'd have exactly what I'm describing, the same momentum in the one mass going one velocity as we have in the half mass going two velocities. We have the same momentum. Momentum works fine, but kinetic energy makes a mess out of it.
Called possibly a flywheel. And we're familiar with flywheels. They do revolve many times according to how much friction is upon them, and then they come to a stop. I don't see any.
Yeah, and it's the same rotation arguments. If I have a flywheel and I want to give it momentum, I can roll a roller on the side of the plane. The plane is here, and I can put a roller here at the midpoint, and I can go half the velocity, or I could spin it twice the velocity at the outside, and I'll gain the same momentum in the flywheel. So again, momentum works, kinetic energy fails. By your theory, the kinetic energy is twice as much kinetic energy on the outside, but yet I don't create twice as much energy in the flywheel. You put twice as much energy in because you had to go twice the velocity. Your motor had to spin at twice the velocity to spin it from the outside. You had to use twice as much energy by your kinetic energy theory. Same momentum by my theory, so everything works.
Any problem with that? One can't. They're not fighting each other. They're both going in the same direction, anti-clockwise.
Alright, so let's not argue, right? I mean, anybody watching these videos knows I have made, probably 100 videos talking about this subject of the balance and the oscillating lever, and I never talked about rotating one.
Respect to the lever, respect to the fulcrum. No problem at all. The other scenario is when the weights, well, first of all, we give the velocity to the lever, it's spinning round, and let's say that the lever is stopped in this position here, horizontal, and the weights are allowed now to fly off.
There you go.
And you say, well, this mass, because of its twice velocity compared to this one, would have double the kinetic energy.
It would. That's right. So I create twice the energy going one way and only half the energy going the other way. And how could I do that if the thing was balanced in the beginning?
If they were allowed to fly off, it would be perpendicular to the lever at this point. And quite correct, it would. It would have double the kinetic energy of this mass if they were allowed to fly off. There is no problem with that.
In my opinion, there's a huge problem. You can't have a coupled oscillator and have more energy on one side than the other side. They are feeding off each other's energy. It's just a transfer of energy back and forth. It has to be the same amount of energy. They can't transfer different amounts of energy.
It doesn't affect the situation when they're connected to the levers. I've already explained. If you do decide to look at this video, Gary, please go back to my previous.
Oh, what a waste of time. Amazing asshole. Please go back to. He's going to talk about a video he made 5 hours before he made this video. What the fuck? Yeah, I already responded to that video. It's a pile of shit. Again, not even on the subject.
Previous one. I think it's entitled Gravity Cannot Be Evaded.
So he has to think about a video he made 4 hours before he published this video.
Please do a review of that. I think that's getting to the point.
It's nowhere even close to the point. It's such a distortion and perversion of the argument. I mean, we're making a simple argument. You have a bathhouse here and you have a bathhouse here. You're going to walk between the two across the sand on a very sunny day. And the argument is how tan you're going to get is going to be completely dependent on how fast you go across that field of force of sunlight. The slower you go, the more sun will hit you. The faster you go, the less sun will hit you. That is an indestructible, perfectly rational statement that just can't be refuted. And what did he do? He just decided, no, let's just pretend there's no beginning and end to the amount of time that they're in the gravity. So we'll just measure it like I said, I could just have a guy sit on a chair and then I could have a guy walk around in circles. And then I would argue that somehow there's a difference in how much force they're going to be affected by. No, of course there's the same amount of force because they never exit the force. It's just such bullshit.
Clarifying the the discussion about what you were saying and getting down to the nitty gritty.
It's like you're passing the sun. You're in a spaceship and you're going to pass a sun. He said that analogy means the sun goes forever. There's a sun here and a sun here and a sun here and a sun here and it never ends. It's an infinite amount of suns. So I never pass the sun. And then he says that's a way of pointing out how time doesn't matter. Well, of course, in that scenario, time wouldn't matter. But that's not the real world. The sun is, there's only one sun. There's not an infinite row of suns. I mean, it's just such a distortion, such a perversion of the argument made. Ugh. Disgusting.
And I think it debunks.
Oh, it's just disgusting that he can use that word. God damn. It evades, completely evades the argument.
Quite well what you're saying. So I'd like to hear you do a review of that, please. Bye.
Yeah, I'll just repost my video pointing out if something's heading for the Earth at 500 miles an hour and it travels 50 miles, well, if it travels those 50 miles in 1 second, then it's only going to be traveling 509 miles an hour. So in 50 miles of gravity, it only gained 9 miles per hour in velocity. And then if I just take an object that isn't moving, and I let it move the same 50 miles, well, it's going to have to take quite a while to do it because it's going to have to build up its speed. So it's going to be in the gravity 15 seconds, and it's going to gain 150 miles an hour in velocity. So I already explained this. You're an idiot. Distance is a symptom. Okay, it's a symptom of the time. It isn't the cause of how much force you collect. The distance is just an emergent consequence. It is a side effect. It is not the cause. The cause of gravity is time in the force. If you don't spend any time in the force, it won't move you. The more time you spend in the force, the more it will move you. Period. Ugh. Noxious. You hate these people. Alright, anyway. So that's probably enough. Oh, 42 minutes. Definitely enough. Eek. Alright, so till the next time and such and so forth and whatnot. Blah, 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 blah.